We're going to look at using disks when we rotate things around a vertical axis in this video. So if we rotate around a vertical axis, the main difference is instead of the disks standing up next to each other, the disks are going to lie flat. And so the main difference there is they're going to lie down, and they're done with respect to dy. So that means the thickness of the disks are going to be dy on these instead of dx. So let's do an example. Take the area bounded by y equals x cubed, the y-axis, and y equals 8. I'm going to do a rough drawing of this, and then I'm going to do a better drawing of it. So I'm going to come over here and draw this first. Y equals x cubed looks like that. The y-axis, of course, is here. And y equals 8 is up here. So the area that's enclosed by all of these is this bit inside of here. So let's come over here and make a nicer drawing of it. Draw my axes. And the only part we need is really this bit here. Looks pretty much like a parabola, except it's supposed to be steeper. So we've got this. And we're taking the area inside of here, and we're rotating that around the y-axis. So if we do that, on the other side over here, we get this, and we're supposed to slice this up into disks. Now, what we would get out of this, of course, would be a thing that's shaped kind of like this, and the disks are going to be sitting on top of each other like that. So I'm just going to draw in one disk again, just in the middle somewhere. And we've got to again work out the thickness and the radius. Now, the thickness here is dy. It's a tiny change in from the bottom to the top of that disk, and so that's a tiny change from one y value to the next. So thickness is dy. Now we've got to work out the radius, and so we need these 2 points and the line between them. But we need this in terms of y. So since y is our variable, we're just going to pick, we'll take this, the y coordinate is y, but we've got to figure out what's the x coordinate. Now, on this thing, we've got y equals x cubed. So if you solve this out for x, you get x is the cube root of y. So we get that for this point. And keep in mind, you can call this point x cubed, or you can call it cube root of y comma y. They're both the same. It's just one's giving it in terms of x and one's in terms of y. What we need for this problem is, of course, this. Now this point over here, its x-coordinate is 0 because it's on the y-axis, but its y-coordinate is the same as the y-coordinate of this because they're the same height. So the y-coordinate of this is going to be y. I'm gonna erase this because we don't really need it. And so the radius is just the length of that purple line. So from here to here, it's the difference in the x coordinates. So the radius in this case is cube root of y minus 0, or just cube root of y. So that means, after all this, a volume is going to be pi times the integral of radius cube root of y squared times the thickness dy. And now what about our endpoints? Endpoints for this thing, again, we go from one end of the shaded area to the other. In this case, we're doing it with respect to y, so we're going from here to here. And so down here, this is at y equals 0. And up here, this is at y equals 8. So those are our endpoints. And now we just have to work this interval out. Let's see. All right, the cube root of y, that's y to the 1/3 power. When you square that, you get y to the 2/3 power. Let's see, y to the 2/3. If you add 1 to 2/3, you get 5/3. And so we have to divide by 5/3 or multiply by 3/5. We're going from 0 to 8. So we get 3/5 pi times 8 to the 5/3 power. Okay, 8 to the 5/3. So you take the cube root of 8 and you get 2. Then you raise 2 to the 5th power and you get 32. So it looks like we get 32 times 3 is 96 pi over 5. And that's it. Now let's check it using the grapher. Let's see, what we had on this one was, let's see, at the top we had y equals x, or we had y equals 8. Then we had x cubed. And so we were looking at the area. Let's see, from, in this case it was from 0 to 2. Because everything on here, we have to put it in terms of x. But if we shade that area, we took that area and we rotated it around, that's not right. We rotated around the y-axis. Well, the y-axis is the line x equals 0. If we rotate around there, we get this, which is exactly the thing we were looking at. And if I turn this up to more rectangles, then yeah, it looks about right. And let's see, how does this compare? 60.329. Well, the answer we got was 96 pi over 5. When I put that in my calculator, I've got 96 pi over 5, 60.3185. 3185 versus 32. Yeah, that's correct. If I were to make this, my computer's probably going to start cutting the fans on and everything. If I do this and wait, yeah, 62.3186. Yeah, it's getting closer. All right, so I want to look at something though. This right here, if you try to turn down the opacity on this and you start looking at the different parts, notice it's no longer giving us disks, it's giving us a cylindrical shell. And so that's a method we're going to learn in 6.3. But you can still use this to check your answer. So let's see, that's the only example of this I had. What we're going to do is we're going to look at washers next, and then we're going to look at a bunch of different types of examples. So we'll stop this video here.